We'll start in about a minute. Today we'll be in the last chapter that will cover section 1. There are two parts. Part A is about the distance formula, which means that we'll be able to find the distance between any 2 points in the xy plane. And closely related to that are equations of circles, as you will see. Okay, we'll start by reviewing the Pythagorean Theorem. The Pythagorean Theorem has to do with right triangles and the lengths of the three sides of a right triangle. So if we label the length of the hypotenuse, length C, and the lengths of the two shorter legs, A and B, then the Pythagorean theorem says if you square the length of the hypotenuse, that's equal to the sum of the squares of the length of the two legs. So that is true for any right triangle. So we're going to use the Pythagorean theorem to help us find the distance between 2 points in the xy plane. So we'll start by plotting these points, the points with coordinates 1, 2, and 5, 4 in the xy plane. So the point 1, 2 and the point 5, 4. Okay, so there are the 2 points. Now find the distance between those 2 points. Well, if we form a right triangle or construct a right triangle, if we draw a line segment between those 2 points, this is going to be the hypotenuse of a right triangle. And then we connect horizontal and vertical line segments. So I'll label the hypotenuse D to represent the distance between those 2 points. And then all we have to do is find the length of the horizontal side and find the length of the vertical side of that right triangle, and then apply the Pythagorean theorem. And then we'll be able to find the length or the distance between those 2 points. So what's the length of the horizontal side? So the ordered pair of this point is 1 for x and 2 for y. The ordered pair of this point on the right triangle is 5 for x and 2 for y. The length of the horizontal side is just the difference in the x-coordinates. The x-coordinates are 1 and 5. So we could say the length of this side is the absolute value of 5 minus 1. But we know that it's going to be 4, right? And then the length of the vertical side, let's do the same thing. The ordered pair for the vertex of the right angle is 5, 2. The ordered pair for this point is 5, 4. And so the length of the vertical side is the absolute value of the difference between the y coordinates. So we could write the absolute value of 4 minus 2. If we just take out the right triangle, label the horizontal side 4, the length of the horizontal side is 4, the length of the vertical side is 2, and D represents the distance between those 2 points. Using the Pythagorean theorem, that will tell us the length of the hypotenuse, which is the same as the distance between those 2 points. So apply the Pythagorean theorem, we get D to the second equals 4 to the second plus 2 to the second, or 16 plus 4, or 20. So if the distance squared is 20, then the distance is the square root of 20. And we simplify square roots when possible. So the square root of 20 simplifies to 2 times the square root of 5. So that is the distance between the points 1, 2, and 5, 4 in the xy plane. Okay, we can derive a distance formula using the same ideas from this previous example. So we want 2 points to be represented by the ordered pairs x1, y1 and x2, y2. We'll draw a diagram just to help us. So I'll label this point x1, y1, and I'll label this point x2, y2 in the xy plane. And so we find the distance between those 2 points by constructing a right triangle. So we connect the 2 points with a straight line segment. That's going to be the hypotenuse. And then we connect horizontal and vertical line segments to form a right triangle. Okay, we're using variables to represent actual numbers, so we can't put an exact number here for the length of the horizontal side. So what do we have to do instead? So I sort of gave you a hint up here. In this example, this ordered pair is 1, 2, 1 for x and 2 for y. The ordered pair for this one is 5, 2, 5 for x and 2 for y. The length of the horizontal side is the absolute value of the difference of the x coordinates. So the absolute value of 5 minus 1, or the absolute value of 1 minus 5 gives you the same thing. Okay, so we'll use the same idea. The coordinates of this point on the right triangle, the vertex of the right angle, this x coordinate is x2, and the y coordinate is y1. And so the length of the horizontal side can be represented by the absolute value of the difference of the x coordinates. So the absolute value of x2 minus x1. or the absolute value of x1 minus x2. Either way it's going to give you the same result. And then the length of the vertical side is the absolute value of the difference of the y-coordinates. So we can write the absolute value of y2 minus y1. And I'll label the length of the hypotenuse as d. D represents the distance between the points x1, y1 and x2, y2. So we use the Pythagorean theorem, square the length of the hypotenuse, d squared, and then that's equal to the sum of the squares of the lengths of the two legs. So x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Since we're squaring, we no longer need the absolute value symbols. So we remove the absolute value symbols because when we square a number, we will always get a number that is non-negative. But we want to know what d is, so d, the distance between those 2 points, is the square root of the entire quantity x2 minus x1 squared plus y2 minus y1 squared. This is referred to as the distance formula. More specifically, it's the distance formula to find the distance between 2 points in the xy plane. It's based upon, or it's derived by using the Pythagorean theorem. Okay, we'll do some examples using the distance formula. Find the distance between each pair of points. So you can use the distance formula. Just make sure that you memorize it perfectly if you're going to use the distance formula. Or another valid way is just draw a right triangle, find the lengths of all of the horizontal and vertical sides, then use the Pythagorean theorem to find the length of the hypotenuse, which is the distance between the 2 points. It doesn't matter which of the ordered pairs you label x1, y1 and x2, y2. Those are completely interchangeable. So I'll just pick the ordered pair 3, 2 to be the x1, y1, and 7, 5 the x2, y2. And then I'll write the distance formula. The distance between the 2 points is the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. So if we apply the distance formula, we get the square root of, 7 minus 3 quantity squared plus 5 minus 2 quantity squared. And then we just do the arithmetic. So inside the square root, 7 minus 3 is 4 squared. 5 minus 2 is 3, so plus 3 squared. Then the square root of 16 plus 9, which is the square root of 25. So the distance simplifies to the whole number 5. So alternative, just draw a right triangle. There's 7, 5. The other point is 3, 2. Construct a right triangle. Find the lengths of the horizontal and vertical sides. So this point on as it relates to the x-axis goes from 3 to 7, so the length is 4. This point goes to that point. Related to the y-axis, it goes from 2 to 5, so the length of that is 3. And then the Pythagorean theorem, d squared equals 4 squared plus 3 squared, and so on. So you still get the same result. Okay, make sure that you know the distance formula. Make sure that you memorize it perfectly. It only takes one little error to throw everything off. Okay, the next example, let's find the distance between the points 6, -1, and -2, -8. So if you want, it's not required, but if you want to assign x1, y1 to be one of the points and x2, y2 to be the other one, and then it might not hurt just to write down the distance formula. The more times you write it down perfectly, probably the easier it will be to remember. Hey, but always be careful with the arithmetic, especially when negatives are involved. So the distance is the square root of the sum of squares. So x2 minus x1, the quantity -2 minus 6 squared, plus y2 minus y1, quantity squared. So -8 minus -1, quantity squared. So inside this set of parentheses, -2 minus 6 is -8. So we have the number -8 squared. Inside the other set of parentheses, -8 minus -1 is the same as -8 plus 1, quantity squared. When we square the number -8, we get 64. And then -8 plus 1 is -7, so -7 squared. So when we square -7, we get 49. And 64 plus 49 is 113, so we get the square root of 113. The square root of 113 cannot be simplified any further, so that is the distance between those 2 points. Okay, the next example, find the distance between the points -2 or -7, -2, and 4, 6. So take a minute or so to find the distance, and then type in what the distance is. Hey, what did you come up with? Okay. So the square root. Well, you get to pick on how you go about the picking the points. So I'm going to pick 4 minus -7 quantity squared, and then plus 6, the quantity 6 minus -2 squared inside the square root. So 4 minus -7 is 4 plus 7, which is 11, so 11 squared. And 6 minus -2 is 6 plus 2, or 8, so we have plus 8 squared. 11 squared is 121. 8 squared is 64. So the square root of 185. 185 is 5 times 37. So the square root of 185 cannot be simplified any further. This is as simplified as it can be. Okay, one more example. Find the distance between the points -9, 4, and 5, -3. Okay, take 30 seconds and find the distance, and then type in the answer. So some of these you can do in your head. For example, -9 minus 5 is -14, and the number -14 squared is 196. 4 minus -3 is 7. 7 squared is 49. And 196 plus 49 is 245. And the square root of 245 can be simplified because 5 times 49 is 245. So this just turns out to be 7 times the square root of 5. Is that what you got? Okay, but let's write it out. So the distance is the square root of the quantity -9 minus 5 squared plus, remember the plus, and then the quantity 4 minus -3 squared. Okay, negative 9 minus 5 is negative 14. So the square root of negative 14 squared. 4 minus negative 3 is 7, so it's plus 7 squared. So negative 14 squared is 196. 7 squared is 49. So we get the square root of 245. But 245 is 49 times 5. And then the square root of 49 is 7. So 7 times the square root of 5 is the distance. Another thing, if you make a little mistake, sometimes it throws the answer off by quite a bit. So sometimes you can look at your answer and see if it makes sense. So keep that in mind. If you have 2 points that are a long ways from each other and you get a distance of 1.7 or something, if it just doesn't make sense, then you might want to go back and check your work. Okay, now we'll move on to circles. So we'll start by drawing a circle in the xy plane centered at the ordered pair 3, 4 with radius 2. Okay, so I'm telling you what I'm going to be doing, so in the event that you can't recognize my drawing, at least this tells you what it's supposed to be. So in the xy plane, I'm going to plot the point 3, 4. Oh, as always, I don't think well enough in advance. So I'll do it on another piece of paper. So I'm going to plot the point 3, 4. So the point 3, 4, this is the center of the circle. The center is not actually a point on the circle, but it's a reference point. So circle with center at the ordered pair 3, 4. And the radius is 2. So the circle is the collection of all points whose distance from the point 3, 4 is 2. So we can find a few points. If we go vertically upwards, then this point 3, 6 is a point on the circle. This point 3, 2 is a point on the circle because the radius is the distance from the center to any point on the circle. This point, 5, 4, is a point on the circle. And this point, 1, 4, is a point on the circle. And then connect the dots. So pretend like this is a circle. So you have to use your imagination a little bit. Okay, the center is the ordered pair 3, 4. Okay, so what we want to do is find an equation for this circle by using the Pythagorean Theorem. So I'm going to pick a point on the circle that represents all of the points and label this point xy. And then using that arbitrary point on the circle together with the center, I'll construct a right triangle by connecting the center and that point, and then connecting horizontal and vertical line segments. We know what the length of the hypotenuse is. That's just the radius of the circle. It's 2. But how should I represent the horizontal and vertical sides? Okay, so the point of the ordered pair for the vertex of the right angle, well, the x-coordinate is x. It's the same as the x-coordinate of this point. And the y-coordinate is 4. Okay, down here I'll draw a bigger picture of what we have up here. So we have the center, 3, 4, and then we have a point. It's a representative point, xy. And then we construct a right triangle. This point is x4. The length of the hypotenuse is 2. That's just the radius of the circle. Okay, how do we represent the length of the horizontal side? The horizontal side is a movement that is associated with the x-axis, right? The x-axis is horizontal. And so to go from x equals 3 to x equals x, we can say, well, that distance is the absolute value of x minus 3. It's the absolute value of the difference in the y-coordinate, or in the x-coordinates, the horizontal movement. Okay, what about the vertical side? Yeah, the vertical side, the length of this vertical side can be represented by the absolute value of y minus 4. Right, it's the change in the y-coordinates. A vertical movement in the xy plane is a change in the value of the y-coordinates. But y just represents the y-coordinate of any point on the circle. Okay, then we use the Pythagorean theorem on this right triangle. So I'm going to write x minus 3 squared, quantity squared, plus the quantity y minus 4 squared equals the length of the hypotenuse squared, or 2 squared. Hey, this is our answer. This is the equation of the circle centered at 3, 4 with radius 2. So normally, we don't leave 2 to the second as 2 to the second. We write it as 4. So more explicitly, the standard equation of the circle centered at the ordered pair 3, 4 with radius 2 is x minus 3 quantity squared plus y minus 4 quantity squared equals 4. That is the equation of that circle. So the nice thing about the standard equation of a circle is just by looking, we can identify the x and y coordinates of the center, and we can also identify the radius by taking the square root of the number on the right-hand side. Okay. So we used the same idea to derive the standard equation of a circle with center at HK and radius R. So we're going to essentially do the same thing. It's just that this time we don't have actual numbers. We have HK that represents the center and R that represents the radius. So pretend like that's a circle. And we have center at HK. And we pick any point on the XY plane just as a representative. And since the points on the circle vary, we'll use the variables x, y to represent any point on the circle. And then we construct a right triangle and label the sides. And then apply the Pythagorean theorem. And the result is the standard equation of a circle centered at HK with radius R. Okay, so how do I label the lengths of the three sides? So let's begin with the hypotenuse of the right triangle. So somebody online, type in how to label the length of the hypotenuse. So all it takes is to type in one letter and then press enter. Okay, we got an answer. The radius of the circle is r, so the length of the hypotenuse is r. Okay, now let's type in an expression that represents the length of the horizontal side of that right triangle. This one's a little more involved, but you can still type it in pretty easily. Okay, it might help to label the ordered pair of the vertex of the right angle. The x-coordinate of the vertex is the same as the x-coordinate of the point xy. And the y-coordinate of the vertex of the right angle is the same as the y-coordinate of the center, so k. xk is the point of that, is the ordered pair for the vertex of the right angle. So how do we label the length of the horizontal side?
Absolute value of x minus h.
Yeah, it's the absolute value of x minus h. If you have a horizontal movement in the xy plane, a horizontal movement, the y-coordinates stay the same, but the movement is represented by the difference of the x-coordinates. So we write the absolute value of x minus h. And then the length of the vertical side of that right triangle, if you have a vertical movement in the xy plane, the x-coordinate stays the same, but the y-coordinates change. So the length of this side is represented by the absolute value of y minus k. Okay, then we apply the Pythagorean theorem to this right triangle. So the quantity x minus h squared, since we're squaring, we no longer need the absolute values. Then we add that to the quantity y minus k squared, and that's equal to the radius squared. Okay, so there you have it. This is the standard equation of a circle. The center of that circle is the ordered pair hk, and the radius is r. Okay, so anytime you see an equation that's in standard form, you automatically should know what the x and y coordinates of the center are, as well as the radius. Okay, well, with that in mind, if we're given the center and radius of a circle, we can write the standard equation for that circle. Okay, so if we have a circle with center at 1, 3 and radius 2, then what's the standard equation? We can write it down immediately. The x-coordinate is 1, so we have x minus 1 squared. And then we add that to, let's see, the y-coordinate of the center is 3, so the quantity y minus 3 squared. And that's equal to the radius squared. Well, on a test, this is a perfectly fine answer. If you're typing in equations in Newton, it will want you to simplify when possible. So instead of writing 2 squared, we write 4. That is the standard equation for that circle. Okay, so if it helps, you can write the standard equation of a circle x minus h squared plus y minus k squared equals r squared. So writing this down a few times will help you remember it. It only takes one little mistake to throw everything off. Okay, the next one. If you have a circle, the center is 4, negative 2, and the radius is 3. Okay, the x-coordinate is 4, so we write x minus 4 quantity squared plus the y-coordinate is negative 2, so we write y minus negative 2 quantity squared. The radius is 3, so we get 3 to the second. But we want to simplify a little, so x minus 4 squared stays the same. Y minus negative 2 squared is y plus 2 squared. And 3 squared is 9. So that's all there is to that. Okay, the next one, the center is 0, 5, and the radius is 4. Okay, the x-coordinate of the center is 0, so we write x minus 0 quantity squared, and then plus 5 is the y-coordinate, so y minus 5 quantity squared. And that's equal to the radius squared. And then x minus 0 is just x, so the simplified form for this is x to the second, and then plus the quantity y minus 5 squared. 4 squared is 16. Okay, we can get started on the next part. And after that, we'll pick it up tomorrow from here. But we can at least start this one. We are looking at, in part A, an equation of a circle, but it's not in standard form. So we want to learn how to write equations that are not in standard form into standard form. And we're going to use some things that are familiar with you or familiar to you. We're going to rearrange the terms so that the x terms are next to each other. So rearranging, we get x squared plus 12x. I'm going to leave some space before I write plus y squared plus 2y. Leave a little bit of space before you write the equal sign, and then on the right-hand side we have negative 12. So maybe you can guess what's going to happen next. So a hint is in the standard equation for a circle, we have a binomial squared plus another binomial squared. Okay, we're out of time, but I'll just briefly say we're going to create perfect square trinomials, one out of x squared plus 12x and the other one out of y squared plus 2y. Okay, we'll pick it up from here tomorrow.